Today we're going to talk about section 4.5 logarithmic properties. And then in the second part, we will talk about solving logarithmic and exponential equations in general. All right, what is this so-called change of base formula? Let's start with that. It turns out log base A of x is always equal to log base B of x over log base B of A. It is called change of base formula because notice you go from base A here to base B, right? To base B. Allows you to change your base. Now, for you to kind of understand this much better, in real life, you know, when you think of currency, especially when you travel, right? Let me ask you this, guys. Which two currencies are the most popular ones, the most convenient? The most convenient ones, could you tell me? Most convenient ones are, yeah, among, you know, pesos, yens, all type of currencies, which ones come to mind for being the most convenient? Anyone in the chat you can write, or you can tell me? Let's say you travel to Europe, right? Or you travel to somewhere in the United States. More students are joining. Yeah. Or you are, say, dealing with international transactions. What currency, what type of money is the most convenient ones to use or to deal with? Go ahead. Yeah, someone. Yeah, welcome. Yeah, welcome, Jay. Very good, very good. Okay, guys. So let me help you with that. It turns. Someone wrote something in the chat. Dollars. Mohina. Yeah, you got it. Yeah, very good. Hey, Lung, welcome. Yes, started. Yeah, we are saying that among the most convenient, Mohina, very good. Dollars, euros, right? Yeah, dollars, dollars and euros, right? Yeah, because any other currency can be converted to dollars, right? Any other currency can be converted to euros, right? So these are the most convenient ones, right? When traveling, especially, right? Yeah. So same way here in the logarithmic world, the base could be any positive real number, right? Except for one, of course. But the most convenient ones turns out to be log base 10, right? Which we call the common log, and log base E, which we call the natural log, right? Natural log. Yeah, so these are the most convenient ones, So this formula then allows you to go from any base, in particular to base 10 or base E. And that's useful because most scientific calculators, they have available these functions, right? The common log and the ln, the natural log, right? So at least computationally speaking, it's going to help us, right? All right, so using base 10, for example, log base A of x can be rewritten as this: log base 10, I don't have to write the 10, remember, when it's base 10, of x, the top, this was the top, and then on the bottom, log base 10 of A. Okay. Now, if I decide to use instead base E, I can rewrite log base A of x as natural log of x over natural log of A, right? And I can do the computation. Okay, great, guys. So now let me show you an example of how this change of base formula works, right? For example, suppose they ask you to compute log base 4 of 25, rounding your result to 4 decimal places. Let's do it. Okay, so I am going to use my change of base formula this way. Let's say I decide to work with common log base 10 first. Then I can rewrite this as log base 10. Remember, I don't have to write the 10 there. Understood that is base 10 of what? The one here, the argument goes here, 25. And on the bottom, log base 10 of this base 4, right? That's how it works. Now, if you take your scientific calculator, I'm going to use our Desmos scientific calculator. You just have to go to functions and look for log, right? Here, log, or type log, it's same. 25 on the top divided by log of 4 on the bottom, right? And look, we get 2.321 rounded to 4 decimal places. There is a 9 there next to 1. This should be 2.3219, right? So let's write it here. And that is supposed to be our answer, 3219. Great. Now, let's see what happens if instead of using the common log, I choose to use natural log, right? So then this log base 4 of 25 should be written as natural log of 25 over natural log of 4, right? 4. And let's compute that. It's like instead of dealing with dollars, I decide to deal with euros. It should be the same, right? It should be the same. So let's check that out. So ln of 25 divided by ln of 4. This time I just type ln, right? But for you to see it's the same. But if you prefer, you can click on functions here, and then in your scientific calculator, you will find ln. It's the same. But notice what is important is that we get exactly the same number. Look, 2.3219, 2.3219 rounded to 4 decimal places, right? That's what is important. 2.3219. The same, right? So this is important, same. So, which tells us that we can really choose which one to work with, right? With one to work with. Yeah, very good, very good. Okay, guys. So, great. So now, let's talk about applications of this, right? Let's practice. Remember, guys, practice makes the master, especially mathematics, right? So let me give you some exercises here for you to work on. Can you try number 1 using the change of base formula? This one. We'll give you the hint, log base 7 of 18. It's gonna be the quotient of the logs. You may choose to work with natural log or with common log. It's up to you, right? So choose one and then do the computation, right? Log, let's say you chase common log, you know, I will write here in general the change of base formula. Base A of B equal, sorry, put here X, yeah. Very good, guys. Let's put X is log base B of X, log base B of A, right? Yeah, very good. Right? Yeah, mute yourself if you are not is participating. Okay, great, excellent, guys. Now, Jay, Jay is posting an answer. Okay, Jay, let's see. Great, excellent, Jay. You got it. Yep. Yeah, very good. Let's say you decide to work with common log base 10, right? So this will be log, the one here goes on the top, 18. divided by the one here goes on the bottom, log 7. And this, when computed, should be rounded according to the instructions, right, to 4 decimal places. Okay, so let's do log and of 18 divided by log of 7. And there you go, right? 1.4853 rounded to 4 decimal places, 1.4854, right? Which makes this the answer. Very good. Excellent, guys. So as you can see, it's not that difficult. Just choose a way. Some students might have chosen ln, but you should have gotten the same answer, right? This guy. Try number 2 and let's move on, right? Let's try this quickly. Do this one. Base 12 of 53.24. Very good. Try this. Again, use 2 logs, right? For the sake of convenience, not for the sake of convenience, for the sake of variety, I'm gonna use ln now. So use ln and then get your answer, right? Doesn't matter which one you use. I can see. Okay, very good, very good. Yeah, use your scientific calculator, guys. This time, this guys, 9. This time, if you are using natural log, then you have to write ln of 53.9 on the top, ln of 12 on the bottom, right? And see what you get here. Take your calculator, ln, you can just type ln or look in the functions. The same, yeah, so ln of 53.9 over ln of 12, okay? Very good, you get 1.6045, right? Rounded to 4 decimal places is this guy, right? You got it, guys? Yeah. We're gonna use this eventually, so make sure you are okay with this. So 1.6045 is this guy. Excellent. Great. So we know how to use the change of base formula, right? Very good. Now let's talk about some properties of logs in general, okay? So it turns out these logs have properties that they somehow inherit from the properties of exponentials or exponents in general, right? The first property is called the product rule, And what it says is the following: log base A of u times v is equal to log base A of u plus log base A of v. The log of a product is equal to the sum of the logs, right? And then this comes from the following fact when you deal with exponentials, for you to kind of make the connection. It comes from the fact that when you multiply a to the n times a to the m, you end up with a to the n plus m, right? This is a fact from exponentials. Now, remember, the log is the exponents, which you raise a base to get some given number, right? So because of that, comes from here, right? The sum of the logs, the log of the product. Great. Then there is other property called the quotient rule. Quotient rule for logs says that log base A of u over v is equal to log base A of u minus log base A of v. They say that the log of a quotient is the difference of the log, right? The difference of the log. Now it comes from the following fact when you study these exponential expressions, right? Look, a raised to n divided by a raised to m is equal to a raised to n minus m, right? From there, right? Remember, the log is the exponent, right? So from here, this fact. Third rule, it's called the power rule. What happens if you take the log of a power, log base A of u raised to n. The argument is this power, right? U raised to n. Turns out mathematicians have discovered that whenever you do that, you're allowed to take the exponent here and write it up front in front of the log, this way, n times log base A of u. You follow, guys? Up front, okay? All right, so let's talk about then now application of these three rules, right? Applications, how you use these three rules to simplify this logarithmic expression. We're going to use this later when we solve equations, logarithmic equations. So first example, suppose they say simplify log base 10 of c raised to -4. Professor, how do you know it's base 10? Because if no base is written after the word log, is understood that it's base 10, right? So how you simplify this? Well, I can use the power rule, right? Notice I have an exponent here. Power rule says that I can take the exponent and write it up front, right? In front of the log. So I will end up with this, right? Follow, guys? Yeah. Great. Example, it says 11, 13 because these are taken from the worksheet. You will find them there. Okay. Suppose they ask you to simplify this log base 4 of this quotient, x to the second power divided by y to the sixth power. Well, recall that the log of a quotient is equal to the difference of the logs, right? We saw it here. Difference of the log. So you start with that. Say, okay, this should be equal to log base 4 of x squared minus log base 4 of y to the sixth power, right? Now I'm going to use the power rule, right? The one that tells me that this exponent here can be written up front as 2 times log base 4 of x, right? Minus, same thing here. Take this number 6 exponent, write it out in front of the log. 6 times log base 4 of y. And then there is nothing else to do. That should be it, right? Great. Next. Next on question 15 on the worksheet, says condense. Condense, Professor, what does it mean? It just means write it as a single log. Single log, yes, one log. Okay, this is what I mean when this word condense. They give you log base 2 of x minus 5 minus log base 2 of x minus 2. How can I write this as one log? Well, you kind of think of the quotient rule and apply this quotient rule but backwards. Recall that we said that for the quotient rule, this is true. Log of a over b is equal to log of a minus log of b, right? Here I have the difference. So I can write this as log of the quotient of these two, right? This guy, this guy. This will play the role of A, this will play the role of B, right? So I can sort of go in this direction and say that this should be equal to log base 2 of this quotient. The one on the top should be the first, right? X minus 5. The one on the bottom should be the second, going from left to right, x minus 2. And that's it. This is what it means condense, right? Kind of write this as just one single log. Great. Now, one more example, and then I will let you to work on your own, okay? So this is another example for condensing. It says condense log base 3 of x squared plus 1 plus 4 times log base 3 of x plus 5. Condense. Well, recall again, right, that I can use the fact that the log of a product is the sum of the logs, right? Backwards, right? But before I do that, notice I have this constant term 4 that is kind of bothering me there for me to do that. So allow me to put this 4 first back here as exponent, okay? So what we're gonna do is we're gonna rewrite this as log base 3 of x squared plus 1 plus putting this back here using the power rule backwards, right? So then we do this, right? And you say, why you are doing that, Professor? Well, because I'm preparing the ground to condense this, right? To condense. So now condense. If you condense now, then you can say that this whole thing will become just the log base 3 of what? Well, recall, right? Recall that the log of a product, A times B, let's say, is just the sum of the logs, right? Log A plus log B. Recall that. So following this, right, I have a sum of logs. I can write it as a single log. The log of what? The log of a product of these two guys, right? X squared plus 1 times x plus 5 raised to the 4th power, right? Now, mathematicians often drop this parentheses because they consider that they are no longer needed. So what you will see on your multiple choices for the answer should be just this, right? But this is the argument is this whole thing, the inside of the law. Okay, guys. So now let me let's go over together some exercises, right, for you to practice this the use of these properties, right, towards simplifying or condensing logarithmic expressions. So let's go back here to the worksheet and let me ask you to do some work here. For instance, can you try, we did change of base. Now, let's start with number 5. It's a good one, I think, this one. Can you try this one? Can you rewrite this in simplified form? Can you expand this, right? And the hint, as usual, I'm gonna give you a hint, log, in any base, right? In any base, u times v is log base a of u plus log base a of b. The log of the product is equal to the sum of the logs, right? Yeah, can you try? And then simplify, right? It's a little bit tricky. I see. Jay, very good, very good. But I think you have to adjust a little bit the simplification. Adjust your simplification because the structure is good, but the thing is that when you simplify, you should end up with something else. Try. Yeah, use the product rule, right? But then simplify the first component. Let me see. Gabriela. Gabriela, you made my day. Yeah, you got it. Jay now, or also you adjusted it, right? So now it looks good. Very good, guys. Very good. Yeah, it's a little bit tricky because it's a simplification there, but let's do it together, right? Yeah, following the product rule, we can say that this should be equal to log base 2 of, this is going to play the role of A, this is going to play the role of B, right? Of 4 plus log base 2 of X. That should be it, right? But this part turns out can be simplified, right? Basically, you ask yourself, well, what's the power that I have to place, or the exponent, if you prefer, on top of 2 to get 4? Well, when you run the powers of 2, you will realize that that one is this 2, right? 2. This is just 2. The log base 2 of 4 is just 2, right? And then this cannot be simplified because we don't know the value of x, so this stays there, and that's it, right? This is it. Making the answer this guy. Excellent, excellent. Very good, guys, very good. Now, can we try, let's do one with division now. This one, number 6. Let me make it bigger so you guys can see all this one. Yeah, can you try this? Basically, they say simplify, right? Log base 3 of 2 over 5. And let me write here for you the quotient rule, which says log base a of u over v, log base u of base a of u minus log base a of v. Yeah, this is the quotient rule. Apply it and figure this out. Aha, very good, very good. Aha, Jay, excellent, excellent. Yeah, you got it. Gabriel also, very good, excellent. Excellent, guys. Yeah, it's not that difficult. Remember, the log of the quotient equal the difference of the logs, right? Yeah, so this have to be log base 5 of 2 minus log base 5 of, base 3, sorry, 3 of base 3 of 5. And in this particular example, it is not possible to simplify, right? It's farther. So then you just go ahead and choose this guy, right? Very good. Can you try number 7? Number 7, you will have to simplify. So try guys, this. Yeah, again, hint log base b of x equal, sorry, is a quotient. U over v base b of u minus log base v of v as in victory, right? The log of a quotient is the difference of the logs. And it will make, you will have to go over a little simplification before presenting your answer. Let's see. Gabriela, excellent, excellent. Yeah, great, excellent, good work. Yeah, very good, right? So basically, you say, okay, what will be log base 5 of 5 over x? And we're going to use this, guys, when we solve logarithmic equations. This is going to be, according to the quotient rule, log base 5 of the numerator 5 minus log base 5 of the denominator x, right? But this guy is equal to, when you run the powers of 5, you will see that, the first power is the one that I need, because 1 is the exponent you put on top of 5 to get 5, right? This is 1. It's a property, right? Well-known property that we cover in our lectures, previous lectures. And this tells us that this is it, this guy. Excellent, excellent, guys. This one, you can do it at home. Let's look for other forms. What about this one, number 9? Can you try number 9? Hint, use now the power rule, right? The power rule. Hint, use the power rule. What's the power rule, Professor? Well, suppose you have log base b of x raised to k. The power rule tells you that the exponent, you can write it in front of the log outside, right? Base b of x. Yeah, something like this. Very good, very good. I see students already posting answers. Jay, excellent, right? Excellent. Very good, right? Know how to see that this guy, since the exponent is 6, will be just equal to 6 times log base 3 of x, right? And that is stated here. Okay. Excellent, excellent. Yeah, this is similar. You can do it at home. Let's go over the ones that deal with condensation because that will be important for us to do. But before this one, 12. I think 12 is a good one. Can you try this, number 12? Simplify log base b of y times z cube. Hint, use product rule and then power rule, right? Hint, use product rule and power rule. Very good. Product rule first and then power rule, right? Excellent. And this will help us with our equations. So try to really master this. Gabriela, excellent, excellent. Jay, excellent. Very good, guys. Very good, guys. I am glad that you have understood how to use this rule. Yeah, very good. This, according to the product rule first, is equal to log base b of y plus log base b of z to the third power, right? First. But now, based on the power rule, we can say that this guy, the second component, becomes 3 times log base b of z, right? Very good, guys. So then that is precisely what we have here. Great, excellent. Can you try this one? It's gonna help us again with our solving our equations next. Rewrite this log base 4 of x squared over y to the 6th power using here using the quotient rule first and then the power rule. Use quotient rule and then power rule, right? And power rule in that order, right? Power rule. Simplify. Let us know if you figure this out. Aha. Very good. Try always, guys. Try always. You don't have to be right all the time, but with practice, I can assure you that you will learn. Jay. Excellent. Yeah, you got it. Yeah, very good. Great. All right, let's do it together so we can practice on condensing. According to the quotient rule first, this should be equal to log base 4 of x squared minus log base 4 of y to the 6th power, right? That one first. But also, according to the power rule, right? Remember, the exponent can be placed in front of the log. This will be 2 times log base 4 of x minus 6 comes down from 6 times log base 4 of y, right? And that's it, because I don't know the value of y, I don't know the value of x, so this is it. The farther I can go. Great. So this one is right. Great. Now, let's practice on condensing, which is very important for solving logarithmic equations. Let's use the properties of logarithms to condense, right? The logarithmic expressions. Condense means write the expression as a single logarithm, right? Whose coefficient is 1. Where possible, right? Evaluate logarithmic expression. Okay. When possible, simplify. So can you try number 14? Condense this log base c of t plus log base c of s. Rewrite it as a single log. hint, use product rule backwards. Product rule backwards. Right? I see students readily posting answers, right? So, Jay. Excellent, excellent. Very good. Very good, Jay. Great, right? Backwards, we know that the product rule says the log of the product is equal to the sum of the logs. I have the sum of the logs. I can come back to the product form this way, right? Log base C of T times S. T times S. Now, remember, mathematicians don't write the product symbol, so they will write as TS here, right? So it's here. Excellent. Great. Now, this one very important. This one, number 15. Can you try this? Condense, right? Condense. Log base 2 of x minus 5 minus log base 2 of x minus 2. I see a difference, right? Before it was a sum, now it's a difference. So hint, use quotient rule. Quotient rule backwards, right? Backwards. Yeah, very good, guys. Yeah, use quotient rule backwards. Can you try it? I see. Students posting. Mojina, you made my day. Excellent, excellent. Yeah, you got it. Yeah, this exercise will be used later when we solve these complicated logarithmic equations. We will simplify them first and then we'll solve them. Excellent, excellent, right? We know that we have this property, right? Recall the log of A over B is equal to log of A minus log of B, right? The log of a quotient is the difference of the logs. So if I have the difference, I can go back always to the log of the quotient, right? But in order this way, right? Log base 2. First you write the one that appears first from left to right, x minus 5, right? Here, x minus 5 first on the top. And next, the one that appears next from left to right, like x minus 2 here. To keep them together, right? To make sure that it's understood clearly that this whole thing is the argument of the log, place parentheses there, right? As they have
Professors.
Yeah, go ahead.
I have a wonder why there's the downward denominator is not the x plus 2, because you said minus log 2 and then parenthesis x minus 2. So is it supposed negative equals positive, right?
Oh yeah, but the thing is that there are two properties for logs. Log of the product is the sum of the logs, right? Remember? And log of the difference, log of the quotient is the difference of the log, right? So the idea is when you have a sum, you use a product, as we did before, right? Look, here we have a sum and we turn this sum into a product, right?
Yes.
But now we have a difference of two logs. Difference of two logs, we turn it into the log of a quotient. This is the whole idea.
Oh, God.
Yeah, I understand. Minus and minus, plus, but that's when you don't have the log here, right? You can distribute this, but since you have the log here, we have to follow these other rules, right? You follow now? Better?
Yes. Yes, I got you.
Very good. Yeah, very good, guys. Yeah, whenever something is not clear, don't hold it back. Just let us know and we can clarify. Very good. All right, guys. So bottom line, right? When you see the sum of the logs, you will use the product rule backwards. When you see the difference of two logs, the quotient rule backwards, right? Great. Now this one is the last one I think on this worksheet. Let's try this. Okay, try this. Can you rewrite this whole expression, right, as a single log? Yes, it'll be challenging, but I think you will be able to handle it. I will give you some hints. Use the hint. You know, there is this number 4, is number 3 there that we have to take care of before doing the condensation, right? So hint, use power rule. Power rule backwards first. And then when you put back these numbers as exponents, right? Then use, I see a sum, so use product rule backwards. Okay, yeah. Tricky, yeah. Yeah, but the hint again, try to do this, right? Try to put this back here, and then the product rule in reverse. Mm-hmm. Mm-hmm. Uh-huh. So activity in the chat room. She's good. Uh-huh. Let's see. Mojina, excellent, yeah. Very good. You got it. Excellent. Yeah. First, deal with exponents. Put this with the constants, I would say, right? Put them back as exponents this way. Log base b of y to the 4th power, right? Putting this backward, plus log base b of z raised to the 3rd power, right? Yeah, great. And now condense. To condense, since I see a sum, I have to use the product rule backwards, right? So this can be written as a single log, as this, log base b of the product, the multiplication. Product means multiplication, right? Y to the 4th power times z to the 3rd power, this, right? Now, guys, remember, mathematicians are minimalists, right? They drop things that they consider to be obvious or clear, so they usually drop these parentheses, right? And also the multiplication sign, right? The multiplication sign is dropped. So what you will see on the multiple choices is most likely this. There you go, right? There we go.